All right, welcome. So we had a whole bunch of PRs from last time. A ton of work went in. So we'll go through that and then open the floor for discussion. So we have BFV support right now. It's reusing the BGV dialect with different encoding, but otherwise it seems like it has full support. And in demonstration of that, we have our first BFE noise model, which was another one from the KPZ 21 paper. We've also added a new noise model from the Johannes Manos paper on BGV. So I think there's even more noise models coming. Hey, Asra. So we have two new noise models, and then we'll discuss more noise modeling stuff later. So I added this new context-aware dialect conversion framework. So this is a fork of the upstream conversion framework that allows you to do type conversions where you have access to the value or access to an attribute that is associated with the value. And so we're using that to do the layout materialization, and I think there's one other place I used it in like the secret to scheme conversions when we need to know about like the level and the dimension and all that stuff. So that's using that too. The last thing I'll say about this is I talked to some upstream MLR folks, and I went to they had like a office hours for the new MLIR core steering committee or whatever it is, and I brought this up, and they're like, yeah, this has been asked for a lot. We should probably add it. So I think I might end up upstreaming some version of this to the regular dialect conversion framework, and then we can get rid of it. Okay, so then there were improvements to polynomial approximation. This was mainly bugs that I added that I hadn't fixed. There's still a problem with polynomial approximation I'll talk about later, but it's basically working right now. And then by demonstration, I added a bunch of polynomial approximation rewrite patterns for all of the math ops that I could. So basically all the unary math ops in the math dialect can now be approximated as polynomials, but that's like not particularly helpful because they don't get applied to ciphertexts, right? So it's just like a demonstration of regular arithmetic math ops. But anyway, I'm sure that will be generalized at some point to work on, working on it for ciphertext ops. So there are a bunch of front-end improvements, the main one being that we now have a type inference framework for the Python front-end. Thank you, Alex. And then I think these add support for like for loops and like XGY, like sign extension ops. So like some incremental improvements there. We now have a standalone parameter generation pass that does parameter generation for the scheme of your choice. That used to be bundled in with, I think, the noise validation or something, and now it's separated. The BGV rotate op is now more aligned with the backend libraries that have a particular slot algebra of like 2 by n. So now there's rotate rows and rotate calls op. I don't think we've got a connection between the like one-dimensional rotation abstraction and the rotate rows and calls op yet, but I think that's on the to-do list. And then we'll have there's a new issue that we'll discuss later about like properly modeling the slot algebra throughout the rest of the pipeline. Build time improvements. Hongren noticed an inefficiency I added when I was making the Basel rules for like HEIR opt and HEIR translate. That caused us to rebuild everything twice. I fixed that, and now that cut build times by like 40%, so that's good. We've had a variety of improvements to the mod arith dialect and pipeline. So now we have like a dense attribute for mod arith constant, and other improvements to the parser. And then that has sort of helped us enable a plain text, MLIR to plain text backend. So this, what it will do is it will do all of the rest of the pipeline, but then stop short. Like when you lower to scheme, instead it will just lower to like a packed plain text version of the same ops. So it will do everything in the mod arith, the plain text modulus that you've selected for your scheme, but then just evaluate it in LLVM, like lower to LLVM and evaluate it on CPU. So this is intended to be like help with some manual parameter selection stuff. So you can run your program and see, make sure it's correct for the right modulus. For CKKS, I think it's used to compare with the crypto backend to get precision info, so you can decide what precision to set for your encoding. And then I think there's some passes that Hongren added to basically combine the plain text backend results with the ciphertext backend results in a way that lets you see the precision loss, so that you can decide what precision to use. Yes. Okay. So now that debug function that Hongren had added for the for all the scheme backends, now it passes in a bunch of attributes. Like it can pass in kind of like arbitrary attributes from the op being evaluated, so that now instead of just printing out like the name of the op and the decrypted value for the result, you can also have it print out like the noise bound and any other attributes that get attached to the op. Okay, so back to boring stuff I did. I migrated the code base to Bazel 8 with Bazel mods, so that should improve some of the compatibility issues on various platforms, since we were using quite an old version of Bazel. And then I think at the end of the year, they're deprecating Bazel 7 or Bazel 6 and earlier. So you have to use Bazel mod going forward, and workspaces aren't supported. We still have 4 or 5 dependencies that haven't yet published their things on the Bazel registry, so we can't actually migrate them yet, but they're all in progress of migrating. Okay, so there's, I think last month we had talked about the new alias interfaces, so that we have like nice, pretty names for all of our types and aliases. So Hongren upstreamed that work basically to upstream MLAR, and then we migrated all of our existing stuff to use the upstream stuff, so we don't need our custom interfaces anymore. There's now CKKS scheme parameter generation. I think Hongren will have more to say about that, but in the sense that it's maybe a conservative estimate, or depends on scaling parameters that we don't yet manage. So that's sort of like a placeholder, or to get something working at this point. And then we have. Okay, I was like, when is convert to ciphertext submit? This is the pass I've been working on for the last 2 weeks. So this is the pass that will take the layouts that have been chosen for the IR, materialize them to ciphertexts. In other words, take like a 16 by 16 matrix and convert it to a list of 4 16384 size ciphertext or whatever, using the layout attribute. And then it also includes, so yeah, the initial pass that I did sort of a first version of the layout. I call it layout materialization, as well as implementing a kernel for lineage reduce. And then I have some follow-up stuff that's in progress. But this is going to replace the current pass called lineage to tensor X. Because that one is like hard coding a bunch of assumptions and doesn't have layout support. And then Hongren added an in-place backend optimization. So basically, since Latigo has in-place operations, it will take the SSA form that has every op creating a new value, and then it will convert it. It will basically analyze which values can be reused, and then it will do in-place operations for all those. So I think OpenFHE has this as well, but this pass I think has not been extended to the OpenFHE backend, but it's there, and we can it works for Latigo, and we can extend it as needed. Okay, that was submitted PRs. Now this is in progress PRs. So there's a, okay, I don't know what this is. I think, Alex, was this your PR?
It's like arith.select isn't actually interesting in itself. It's interesting because it's what an if-else statement gets like converted to when you lower it with the data oblivious passes, or from the front end or whatever. And so once we merge that, basically we have support for if, else, etc. in input programs.
Got it. Yeah, and I saw there was another PR that was actually like lowering if else. I think that was Asra's.
It was adding support for if else in the front end, which then turned
Mhm.
it to a select op, and then I hit the bug that Alex fixed since in 1574.
Perfect. Okay.
We've had one of the things Marin's internship, we've had the convert if to select pass in the thing. We just didn't have support for lowering arith.select further because it depended on some of the bit extension stuff that we did for the front end. So sort of by virtue of the front end making on this, we're now connecting some of the dots from last year.
Perfect. Okay, support different flavors of scheme lowering. I don't remember what this is. Okay, maybe.
No, Jeremy left the meeting.
Hit the wrong button.
Maybe his like, oh, he's there.
There we go. Welcome back.
Oh no, we can't hear you though. You're on mute.
You're muted in Meet. There we go.
I pressed the wrong back button on, or the back button on the wrong browser window. So yeah, Hongra, maybe you could say a few words about the different flavors of scheme lowering. I think this is using the. Go ahead.
Okay, so like OpenFHE, they don't respect the mode reduce instruction from the compiler, so we can just stop manage them and let OpenFHE manage it. So that's different flavors of lowering, and that also helps because like in the LW type system, we may get the scale attribute, but if we don't properly manage them, the LW type system isn't happy. So we can just make the OpenFHE pipeline work without the scale, without all the management stuff. And so that's different flavors.
Okay, cool. So on the, yeah, so there's this PR that's been open for a couple of weeks on scale management, making HEIR aware of the concept of scale. And then I think the idea is to do like rescale ops to make sure the scales align. There were some blockers on that. I think Hongren is working on it. There's a new BFV noise model. I'm not familiar with this paper, but that's the, yeah, I guess the 5th or 6th noise model that we have in the system now. So this is very excellent. So there's a PR open for doing polynomial eval lowerings in the monomial basis. So it has a Patterson-Stockmeyer implementation as well as a Horner's method implementation, both in the monomial basis, and this is what I took that. I think this one is going to be ready to be merged today, but I started on generalizing the lowerings by adding a dialect interface. So these ones only worked on modarith, but this one will now work on anything. And what you do is you have a dialect interface that you attach to a dialect that says, here's my multiplication op, here's my addition op, here's how I take a constant and turn it into a type in my dialect that I can use. And so I've tested the dialect bindings, and it works for arith, for modarith, and for LWE. So or for like CKKS, BGV, and stuff. So I think that should be fine. And then I ported one of the two lowerings, and I was going to port the other one once this goes in. Okay. Okay, so then I've also been working on the extending that convert to ciphertext semantics pass to have a linear matvec kernel. So that is basically done, but doing that made me realize there are a bunch of, I think this had been brought up and I had kind of like pushed it aside and said, oh, we'll figure that out later. And now is the time where I had to figure it out. That like basically if there's too many implicit assumptions around like how repetition is done in the ciphertext. And so I have made that explicit now. And we had some support for this. Like there was an attribute already in the TensorX dialect called SIMD packing attribute. And I sort of extended that and made it a little bit more precise. And so now like there's like a precise semantics for how you take, say, like a 4x4 matrix. If you put that in a ciphertext of size 32, you're not using all the slots. And so you have to decide, okay, am I going to replicate this matrix this way, or am I going to replicate it this way before applying the layout? And those give you two different layouts, and there's really no way to tell what to do unless the user specifies it. So with that, I was able to get like a Halevi Shoup kernel in there, as well as extend the pass to support this alignment attribute. What I haven't done yet is like decided on, like have the layout selection pass decide on what to do there. So I'll have to do that in some follow-up work. But then I have another PR I haven't pushed yet where I've started to do like an end-to-end, like basically replacing the old TensorX to lineage or lineage to TensorX pass with our new layout optimization pipeline. And there right now I've run into the problem where the optimizer pass is not actually selecting a diagonal layout yet. So I have to basically force it for now until we have something that can smartly select, oh, this should be diagonal layout and it's worth it to do it here. Okay, so there's a PR. The Belfort team has been helping. I think Wouter ended his student researchership like 2 weeks ago, and the rest of the Belfort team has been helping us get on board with their latest design. I think Wouter will be starting again as student researchership has been extended, starting in like May or something. So he'll be continuing on that. But yeah, so now we have like this has like a README with how to get access to the latest design and build stuff for that purpose. Then, okay, so this was, I think, Oscar's work. There's the layout optimizer pass. So we had the layout selection and forward propagation. Now this is the Felipe style back propagate to try to hoist the layout conversions up towards the top of the IR, and then try to like combine things and fold things. So that is like a first version of that pass is basically ready. Alex, you pushed this and I haven't had a chance to look at it yet, but there's tensor support in the front end now. How is that going?
So the tensor, the front end will now happily emit the correct like ranked but dynamically sized tensor types, slap an attribute on the function argument telling me what the actual shape should be, and now I just need to write the boring part, which is in C++ MLIR, trickle down the shape inference pass. And there's like various, like I looked at the toy version of this, which I linked from the PR. Unfortunately, that one doesn't actually work. It just uses some like shape inference magic that only the toy ops have. But I think Onyx has a version of this, and I'm actually thinking that the like contextual dialect conversion framework may be a really cheap way to do this as well. But yeah, it's the sort of annoying part about doing shape inference and MLIR is that obviously lots of things already do shape inference, right? All the type inference that the ops do already does hold up that logic. So it's just finding a least annoying way to write a pass that doesn't require listing, 27 different ops or something.
Sure. I mean, in the dialect conversion framework, like in the layout pass, I have I have a pattern that just like generically handles any op and just does type conversion on the op. So you might be able to use that to avoid like listing every op.
Yeah, I think and it's a great example of why you need context-aware conversion, right? Because if you did the normal type conversion, it would just always be the input type, would just always be like question mark X something. But obviously, depending on what branch you're in the program, that could be like ×2, ×3, times whatever different size. So it could also be a fun little motivating example for why you want a context-aware dialect converter.
Okay. Okay, there's a PR for supporting SCF if in the front end. We talked about that. There's also a PR with a bunch of AES kernels in it. I think we wanted to do some benchmarking on the Belfort FPGAs, as well as any other hardware platforms for CGGI. And so Asra went ahead and implemented all these AES kernels just in pure MLIR. And I think our idea is to hopefully put them in Python and have them be in the front end. And then one of our student researchers is working on CKKS on TPU. And so there's some PRs that have the backend dialect for that API and then lowerings to that in CodeGen, I think. Okay, whew. This front half of the meeting is getting longer and longer every month. Okay, notable new issues. So we talked about noise modeling with programs that have affine loops. So there are some places, quite a few places in the code base where we emit or preserve affine loops because unrolling would cause compilation times to be too long. But those struggle to do noise modeling because the data flow framework doesn't let you like insert manual hooks to deal with for loops. So it will just like iterate through the for loop and do the lattice join operation until it reaches a fixed point. And in our case, it will like never reach a fixed point and it will just, noise will blow up forever. And so what we want to do is, I think there's sort of three things. One idea is to use lineage ops instead of affine for where it makes sense, because then you can say like, so like if you have like a loop and you're rotating a ciphertext by 1 in each loop, then what you can do instead is you can do a lineage element-wise op where you say, okay, just have all of the shifts that you want to do your rotations as like elements of a tensor, have your ciphertext, and then do like an element-wise shift of the ciphertext by every single rotation. So that would express the same thing. And then maybe if you're like summing all those together, then you can follow that up with like a lineage reduce op that sums them. So that's like a nice semantic way to describe the computation you're doing. I think that one of the problems with that is that is still not enough to do noise analysis because you don't know how that is later going to be optimized. If you end up using all n of your rotation keys versus doing something with a smaller number of rotation keys, but having like a higher depth of rotations, then the noise impacts will be different. But if you make some assumptions, then you can still get some result from the noise modeling. The other thing you can do is you can just unroll all your loops. And then the third thing you can do is we could try to properly support affine for. So the idea there is you maintain some invariant, the thing that you want to track across the loop bound, whether it's like dimension or level or noise. You have some pass that will say, okay, you have to have the same value at the start of each loop iteration, and then you have to insert management ops at the end of the loop iteration to maintain that invariant. And then you can do noise analysis through, because you know at the end of your loop, it's going to be whatever is the invariant is the noise. And then we had some ideas to do stuff like, you know, have this pass be smart enough to like maybe you don't really need to bootstrap every loop iteration and you could bootstrap every 4 loop iterations or something. So then what you could do is you could determine that by like actually enumerating all the loops to loop iterations, because we have static loop bounds. And then you could say, oh, I can bootstrap every 4, so I'll unroll this loop by a factor of 4 and insert the management ops only at the end of that, and then you will get your better noise growth. And I think generally maintaining affine for loops support is important, because I think that we want to support any stupid program that someone writes. Like we want to have like full generality rather than forcing things to be in like a limited computational framework, even if that means the program is not as good as it could be otherwise. But yeah, so I think since neither lineage or affine for is supported yet, what I've done is for my new code, I'm just unrolling the loops. So like for the layout conversion framework, my lineage kernels all just have unrolled loops now. Okay, use MLIR resources to capture large constraints in the IR. I think right now we have something else, but there's, I don't know what's going on in this issue. I think it's ML weights, static ML weights are big if you materialize them in the program, and we'd prefer to load them from disk at runtime.
Yeah, that's basically it. Basically, like the old solution that I had for OpenFHE was just writing them out as serialized weights in serial. But Hongren suggested like this be pushed further up the stack so that we could even like import programs like with MLIR resources on disk, and then the entire like, you know, chain of passes minus like some modifications that do need to look at the constants would have those constants be on disk, and we would like lower the compilation time as well by not having to like see these large constants.
Okay, so there's like a MLIR proper formalism for doing this, and we have to figure it out and use it. Okay. The next one, oh yeah, so the main thing that causes our build time to be really slow, you know, besides it being LLVM, is that we use this MLIR runner thing for doing like JIT compilation of MLIR code to execute it to see the results. And the problem with MLIR runner is it pulls in every single upstream MLIR pass and dialect. And most of those we don't depend on, but they get pulled in through that. So if we remove the uses of MLIR runner and just lower things to LLVM and run it from there, then we will get rid of like probably half of the compilation time as well. So that's in there. Okay. So the main remaining problem with our polynomial evaluation and polynomial approximation is that converting, like when we do polynomial approximation, we do it in the Chebyshev basis, which is like the numerical methods approved way to do anything with polynomials. And when we convert it back, right now we convert it back to the monomial basis in order to evaluate it. And then the polynomial evaluation lowerings are in the monomial basis. This has numerical precision issues. Just converting from Chebyshev back to monomial basis, if the degree is larger than like 40, will have like overflow problems. So that's already bad. And then it's just like a waste of effort versus having some polynomial evaluation method that just stays within the Chebyshev basis. And there are plenty of them, but this is something that we would have to add. So I have an issue here to basically, and like links to some papers that have this. This would be like a good follow-up project for anyone who wants to do polynomial evaluation stuff. Okay, we have a bunch of macOS users who are complaining about the build. I added a CI runner for macOS that basically works, except for it doesn't work for the front end, and it doesn't work for anything that uses MLIR runner, because I don't know, the MLIR runner errors are like cannot find JIT compiled symbol. So like I don't know what that's the same issue we're seeing on Forge Asra. Is showing up on the macOS CI. So I don't know what's up with that. Getting rid of MLIR runner might just fix that problem. But then the front end, the problem is that what's the problem? The problem is maybe it can't find Clang. I forget what it is. There's some issue with the like JIT compiling C code on the fly that we have that's like assuming it's running on Linux. So those tests basically fail. But the rest of the tests run.
Actually, can you send me those errors? Because it might be something as dumb as the fact that like certain linking, like we might hard code certain linking strings because we assume we're on like a Linux system.
I think it's exactly that.
Linking OpenMP or something, you know, like or not linking like standard lib the right way because because I think when we call Clang, also it might not actually be Clang or it might be really old version, right? Like macOS is annoying that way. So yeah, happy.
I think and I think right now the CI is still failing because I keep fucking up the like I try to have like a Bazel query to tell which tests to run. Like it builds fine, but then when I test it, I'm trying to get it to like get all the tests that it could run and exclude all the tests that fail by like writing a Bazel query string that sort of does the right thing. And I can't get it to, I can't get the syntax to work with GitHub Actions. Like it keeps giving me garbage. So I don't like test it. I just like push the PR and wait for the next scheduled daily run to see if it succeeds, and it always fails. So I have to fix that. But anyway, that's an issue there. If we get that working, then hopefully we can just like point macOS users to the CI and say like your system is messed up because this is working and yours is not. I mean that's maybe I've been trying to get someone on the Bazel team to help me with debugging tools for this, but no one is bit yet. So I'll try to keep at that as well. Okay, so the matrix vector multiplication kernels only work when the number of rows is less than or equal to the number of columns. I don't know what kernel to use when the number of rows is bigger than the number of columns. I haven't tried to dig into the literature too much to find out, but I just filed an issue because maybe someone knows. I also want to make the front end pip installable. I've started doing some background research on how to do this, but it involves compiled C dependencies, and that is a whole mess. So it's on.
I think this might actually be a misnomer because the front end is already pip installable, right? The Python part. It's really making like our HEIR compiler and making FHE, the dependencies be pip installable, right?
Well, no, because those dependencies would be shipped already compiled.
Yeah, that's my point. Like,
the-
my point is like it's like the front end, the Python front end part is like
Yeah,
pip installable.
maybe
Python,
pip distributable.
Yes, I
That's
think
what we want.
like I guess also like really it's HEIR and OpenFHE that we need to make pip distributable, right? The front end
Yeah.
is just Python.
Yeah,
I think
I don't think that's particularly difficult in the sense that we can like build them for the system we need, right? Like you have a Docker container, it will build it from source, and then it will have the compiled, like the shared libraries and the compiled binaries, and we just need to like figure out which existing systems can orchestrate all of that for us and publish things to PyPI without us having to do it manually for like 10 different
I
platforms.
think it's done before. It was always like the pip install does actually like build from source, and that's just quite painful with both LLVM and OpenFHE.
Yeah, and
Like,
that's going to be a non-starter for us too, because we have Bazel, right? Like I don't think you can pip install and have it run Bazel. Yeah. Anyway, so yeah, so that's on my to-do list. I was hoping I would do it before the conference. Maybe I'll end up doing it like on a plane flight when I can't sleep or something. But we'll see. Okay, and then there's an issue to so the BGV rotate calls and rotate rows. Eventually, we want to have not only like proper support for like the slot algebra for like the case that everybody uses, which is 2 by n or 2 by n over 2. Like in that case, like all of our passes that do like layout optimization and implementing a shift network and stuff, they all assume we have one-dimensional rotations when we actually don't. And so there's like some overhead there. So this is an issue to like properly support the slot algebra throughout the whole pipeline. And so it's like properly support the thing that everyone uses, which is 2 by n over 2, and or properly support a generic slot algebra. So like have a slot algebra somehow encoded in the IR that says like this slot algebra is cyclic. So you do actually have one-dimensional rotations, and then allow the rest of the pipeline to like use that information to come up with better optimizations. So that, I mean, that it's just there for tracking. Okay. That was 40 minutes of review from what happened in the last month. Now I mean, I kind of like covered the main issues here that I wanted to discuss. So I'll leave the floor open.
So just a bit to say about the noise analysis. So we thank Isaac for contributing the model. And now we almost have all the noise models in the literature for BGV and BFV. And for CKS, we have the plaintext backend PR landed, and we can use that as a starter for our CKS noise modeling. And we don't have much progress in the parameter selection part because I'm still working with the noise model. Okay.
Cool. So what maybe I can ask, are there parameter selection models that do something more sophisticated than sweep over the parameter space and see if take the one that is most efficient for the noise model that is being evaluated? Okay, when we did this for CGGI, we said, okay, you've got this grid of dimension and the various security parameters, and then you try to run it. What do? You run it, you see which ones violate the noise and produce garbage, and then you get like a line through your parameter space, and you take the most efficient one that has still 128-bit security or whatever your security level is. So is that what people do, or is there some more sophisticated static analysis thing that people do for BGV BFE?
For OpenFHE, because of their API limitations, there are some complicated process involved. Also, like for large plaintext modules, the current way won't working because like for one level, we have two modules, like two 60-bit modules, and the current one can't handle that. Also, if we are just using a list of parameters, that's like the OpenFHE way for CGGI. But for BGW, like we always have to generate the modules ourselves. So there's quite a lot of space here.
Okay.
Yeah, the like CGI parameter selection problem is like exponentially easier than the LWE scheme ones because it's just not circuit dependent in a meaningful way, right? Like the way at least the way virtually everybody uses CGI nowadays, your parameters are like application independent. Like maybe they're precision dependent or something, right? But like, you basically get to pick and that's it. And like I always joke that that Zama did a lot of work to come up with the answer 4. Right, like they did like two entire papers, and they basically like they analyze all of these things, and then the answer is like, what's the optimal number of bits to use? And the answer is 4, right? And so you can't do that with any of the other things. So I think one of the questions that I maybe even have on is that I remember looking into some of the work like Rachel and Rachel Fayed, or they were doing CKKS noise analysis like quite some years ago, and the problem was that the theory work and the practical empirical results you got from any actual implementation just were not close enough to be useful. And I'm guessing this has improved with the more recent stuff, but like how close, because I know you have this debugging infrastructure now as well, right? How close are we actually getting with these noise models?
So that's my research topic.
Okay, so I guess I'll have to read it when it comes out.
My understanding is we have implemented the like noise model based on the central limit argument, right? That was Rachel Player's paper. Yeah, and like that one was better, right? But I don't know like what is the gap still.
That gives underestimation, so it's not usable generally.
Yeah, that's what we did, right? Like I had a student look at this as a like thesis project at some point, and we sort of quietly dropped the project because the thing just underestimated, unfortunately, sometimes. But not reliably enough that you could sort of just slap a bit on and call it a day. So yeah, I think that that's one of the main concerns I have with like I think it's really I think this is the most important part for HEIR to be doing to make like maybe after like lineage handling stuff, right, which is what everybody wants. But I think in terms of like making the compiler be more useful than a library, this kind of noise analysis stuff is exactly what compilers should be good at, but it just seems like the theory just, it's not easy.
So I'm working on the theory, and next month I may open a PR on that. So you will see the new theory.
Awesome. Yeah, because my concern is like we could spend a lot of time implementing all of the framework and then just have the theory.
That's just the baseline. I'm going to compare with.
Cool. Yeah. Looking forward to you crushing Rachel's work.
Yeah. Okay. So this is fantastic. We've got lots of baselines to work with.
Another thing I want to mention is that the CGGI parameter selection. So in Zama's compilers, they have an optimization like they don't bootstrapping every time, like bootstrapping after 2 times, after 3 operations. So is that API available in the TFHIS library?
No, it's part of their. It's part of their concrete library. And so I looked into this 2 years ago. I don't know what has changed, but at the last like FHE.org, or it was I think 2 years ago, FHE.org, I looked into their actual like concrete optimizer, like the parameter selection optimizer, which they described to me as being like a really complicated nonlinear, basically brute force solver, like because the noise model is nonlinear, and so they have like very, very fine-grained noise modeling, and then like a brute force search to basically solve for the optimal parameters across the whole program. And then when I asked them if the model, like the part of the code base that had the solver was not open sourced. And then I asked them, I said, are you going to open source this? And they said, it's already open source. And I said, no, it's not. And then they said, oh, we'll fix that. We'll open source it. And then I don't think they ever did. So but it's in the concrete compiler is where it's supposed to be. It's not in TFHE REST.
What I mean is that
how can we implement it, right? You just have to do all the like noise tracking and management that concrete does yourself.
So if we want to implement that technique in HEIR, how do we do that?
I don't know.
I'm interested in the CGI noise model as well. So because I'm always working with the noise. But
yeah, I mean,
don't...
we can check if it's been open sourced. Probably better to do that offline. But and then I mean, I'll be seeing them all next week, so I can bug them about it as well.
Okay.
Yeah. Because I mean, maybe at some point they'll want to start using HEIR, right? I don't know how happy they are to continue to do compiler work over at Zama. I mean, maybe they're only doing blockchain compiler stuff now. I don't know. But
I think we're talking about our front end. I think we're a few PRs away from having feature parity with their like NumPy front end support, right?
Well, I mean, they also have the whole like clone of all of scikit-learn, right? Like,
yes.
So that's got a lot.
Yeah, I think they have a lot of like compilery stuff that is maybe not super interesting from a like research academic perspective, but just the engineering effort is quite intense. And so actually, I guess maybe you have one on there. Like one of the next steps for if I finish the shape inference today, tomorrow we'll be doing intrinsics, right? So we can actually do numpy.matmul or something and have it translate to lineage.matmul and express non-trivial programs rather than just sort of like basic binary arithmetic stuff.
Yeah, as far as I understand, the main thing that Concrete has that we don't have yet is like actual kernels for high-level matmul operations for CGI. Like we don't even try that yet. And so the
point of that kernels for that stuff just are a lot less complex in CGI world than in real RLWE world, right? So it's just a lot less stuff.
Yeah, I think there's also there's like the bit decomposition stuff too. Like they like we have something that's like Valter's passes for like high level TFHE rest split things into like uint 16 or whatever, like it does the like decomposition, but like I think there's just a lot of pieces to put together there to like actually get feature parity with Concrete. Yeah, but yeah, I am interested in that.
Yeah, I think the big one is just that they have NumPy, scikit-learn, etc. Right? Just like there's a lot of coverage of things that people want to put into their Python programs that we don't support right now. And I actually don't remember what their Python sort of front end solution is technically. I don't know if it's
I remember they just like have their own API for everything, and then they emit textual MLAR.
Right, but is it self-evaluating? I.e., does compiling a program mean passing it, or does it just mean running it and it will sort of self-evaluate into? Right, because those are sort of the two big things.
There's no parsing.
Yeah, so I think that's what's happening. Right? Like it's not really a compiler; it's more like a very immersive Python API, right?
Right, exactly. It's a very immersive Python API that lowers to whatever their entry MLAR thing is, and then they run the MLAR compiler. And then I guess they do the same thing that we do, and they bind it back to Python, like JIT compiled.
Yeah, so I think that's obviously like much more flexible than the thing we do with the number, but it's also a lot more work to like build and maintain. But yeah, I think the main thing is really just that support for third-party library stuff that we don't have at the moment. And of course, with the ring learning with error stuff, we don't have the kernels that we would need to do the same kind of ML operations.
Yeah, but like the nice thing is that all their lineage kernels are public, so we can implement them if we want to. We can port them. It just hasn't been super high priority for me personally, because I think, at least with Google, the focus is now on encrypted inference. So we got to get some end-to-end like Torch or whatever, TensorFlow Lite kind of stuff into. That's like my main priority. Any other topics? I've been going full steam on the layout framework stuff. There's sort of a lot to work through there. But yeah, I think it's close to reproducing what we already have now with lineage TensorX. And then in its better generality. but yeah, I've only have basically 2 kernels in there, so I think there's a lot of work to implement all the rest of the Lineage kernels. And I haven't even thought about what like a Lineage generic kernel might look like. But that would be like pretty cool if if you know the structure of the loop, right? Then maybe there's just like a generalized kernel that would work for everything, right? That you could figure out the layout according. Yeah. Oh my gosh, I have to really sit down and think about that, because that would be a huge time saver.
Like, and a research paper, coincidentally.
Sure. Yeah, I don't even care about that. Maybe I should. Google wants me to publish research papers, but
Yeah. Cool. I think you already mentioned, right? Obviously, next Tuesday is FHE.org in Sophia, right? So I think maybe some of you are aware that there is supposed to be also the HE standardization meeting, so homomorphic-encryption.org in Istanbul the days before. However, if you haven't been following the news, things in Istanbul have recently gotten a bit spicy. So I know that for our company, at least, the travel advisory is nope. And that might be similar. So maybe if you're planning to go to the HE.org thing in Istanbul, I guess maybe not many of you here, but maybe somebody's watching the recording, make sure you check travel advisories and with your company if you're going on company dime, because unfortunate unpleasantness and civil unrest.
Yeah, Google,
specifically Istanbul places, right, where the event is supposed to be.
Google sent me an email about that and was like, this could be a risk to like bystanders, and like don't join any protests. It's basically the advice.
I'm glad I had to point that out, right? I think that's a good business travel policy in general.
Yeah. Well, when I was in Seoul, I guess 2 years ago now, I was walking. This was after the conference was over, but I was like walking down the street, and then like a protest materialized around me. I was like, oh, this is a march, and they've got like a band and everything. So I walked with them for a while, and maybe I shouldn't have, but there was no tear gas or anything, so I think it's fine.
So now we know you're the person why HR says
Yes. Yeah, I'll be safer in Istanbul,
So actually, are you going to Istanbul first, or are you coming straight to Sofia?
Yeah.
Well, fingers crossed everything goes smoothly then.
I'm
going to be in Sofia anyway, not in Istanbul because of hacks before FHE.
That's right. Yeah.
Let's see. Anything else? Oh, actually, as well, while we have you, I have one semi-related question, which is we talked with Atalysis some time ago about like collecting like the 10 holy input programs we would like to lower. I think AES is like one of them, right, already?
Yeah.
But you have the other 9 by any chance by now?
So that's actually funny that you mentioned that. I literally spoke to Florent yesterday morning and told him that when he comes back from Real World Crypto, Alex, you and I and everyone should meet and like talk about what their progress is looking like. So that honestly, like that's funny timing that you brought that up. But basically, yes, AES was one of them. So yeah, we were like, okay, after Real World Crypto, let's meet and talk about what other like Python front end program style things would be like nice for you all to have. And I'm sure maybe they'll also be at the benchmarking group discussion, and that will maybe inform them as well. But yeah, literally, I will reach out to everyone that wants to discuss like in sort of like fetch roles or HEIR roles, what would be best to do there.
Yeah, actually, I have a new one that like internally at Intel comes up a lot because it came out of the DARPA DeepRive program. It's OpenFHE's public logistic regression training example. It lives out of tree. I'm just putting that in chat here. And it's like a non-trivial program. Like it's 200 iterations, each of which requires a bootstrap, I think. So it's like a fairly chunky amount of computation. And it's also, I think, a like non-trivial amount of just like C++ code to get this running. So I think it's like basically doing 2 like map molds with a bootstrap after each thing because it's running out of noise, or like running out of precision, I guess, with CKKS. The point being that it would be amazing to have this, or like to think about what like a Python front end / high level MLIR version of this would look like even. And I'm also reworking the OpenFHE tracing thing that Intel did for internal testing. And I'm very, very tempted to make it able to emit OpenFHE MLAR dialect as well, because it's just another printer. And that will be like a post-Vira crypto thing. But then if we have like a raise OpenFHE dialect back to BGP, we could even like, actually trace the original OpenFHE thing and see. And I feel like the more we stare at sort of the traces we get from OpenFHE, there's significant potential for optimizing sort of like if you don't need to target OpenFHE because it does a lot of its own copies, etc. So yeah, there's a that's like one more idea. I'm not sure if that fits into like the scope of the 10 programs we were considering. It might be a bit too large, but I think it is like a nice end-to-end example we should consider as like a stress test. Also, just in terms of like, good luck doing the noise analysis of unrolling 200 loops, right? So there's definitely some like stress test potential here for HEIR.
Yeah, I think so too. I mean, it looks like it also does sigmoid approximation and everything like that. So that's like a fun test for what can we do.
It is by no means, I think, the state of the art on like doing logistic regression under encryption, but it does look and feel like sort of a state of the art algorithm, right? In the sense that it's written by people that know it very well how OpenFHE works, and it's using a bunch of fairly advanced things like approximations, etc. And so I think, yeah, so the complexity of that compared to the kind of programs we're currently testing most of the time is just such a huge jump that I think it's really fun. I mean, like internal disclaimer, we can't even trace this successfully at the moment. Like it's it's sufficiently complicated enough that even just tracing it turns out to be non-trivial, right? So, but yeah, once we get that, I think it would be really interesting to look at comparing a high-level version of this that OpenFHE has lower to what the actual OpenFHE code is doing, right?
Yeah, maybe you should open an issue on GitHub to get like a high level logistic training example into Python so we can see what's currently broken. Or we can see what currently isn't broken.
Everything, yeah. I mean, I'm guessing it's going to require some fairly sophisticated layout framework magic, I assume, right? And polynomial approximation that's numerically stable. So yeah, I think we can sort of start with what isn't broken.
Yeah, I mean, I feel like the I can probably get the polynomial approximation stuff done quite quickly. Like it's very straightforward now that the pieces are in place. The main thing I have to do is support like the polynomial attribute, because like the attribute is like parsed and printed as like a monomial basis. And so I don't think I would give it a custom parser printer. I think I would just say, okay, like if it's Chebyshev basis, just print it as like a list of coefficients and be done with it. But like once that's done, like the process of doing the lowerings, I think would be relatively straightforward. Like they're all very, very slight variations of Patterson-Stockmeyer, and like the baby step, giant step thing. So, okay, we're about at the end, unless there's any last minute comments. Yeah, I hope to see people soon. All right, bye everyone.